Cool. So in this one, let's have a look at a few different kinds of procedural texture types and how we can best kind of configure and process procedural textures so that we have a little bit more control. Now, one of the reasons you might want to use procedural textures or just texturing in general is that, and I won't cover this in this course or in this video, but on 3D printers like the J850, for example, you can actually use texture maps and bake out texture maps from Blender or from any texturing software and print those in color as you're printing. So it's actually becoming a more, I guess, industrial design tool set, even though it's not really meant as an industrial design tool set. Yeah, let's have a look at maybe some different ways of creating interesting procedural textures, because they might, even though you might not use them for this project, or you might not use them in this project, you may find uses for them later on. So if we look at our texture section here, we can have there are a huge number of generative methods of creating textures. So aside from image texture and environment texture, there's a bunch of different textures in here, and I won't go over all of them, but I will have a look at a few of them. So some of the more interesting ones. So if we grab color here, the wave texture here, and drop that into our base color, we can see that the wave texture creates these bands or these waves of data, let's say, data between black and white, and these are going to be projected across the surface of our object in one of these three axes, right? Or we can alternatively set up our own mapping type in the same way that we did in the texturing tutorial. So if we select our wave texture here and hit Control T, then we have our generated texture coordinates and our mapping node here. And we can actually start to kind of mess around with how this wave texture is projected on the surface. Now, maybe we don't want to do, maybe we don't want to do the color. Maybe we want to have a consistent color. Let's say we go hot pink, because that's always funny. We can always plug this texture into something like the roughness, so that we get this kind of these bands of roughness or bands of glossiness across our surface that we can control. So we can almost control these. We can start to kind of control the glossiness or the roughness based on this kind of generative input texture. We can distort those bands as well with the distortion, add an extra detail, remove detail, change the scale. Let's go back into the base color so that we can see. And we can start to design these really pretty intricate and crazy materials that, just because they're using our generated texture coordinate system and we're controlling the mapping, they create these really interesting patterns across the surface. And the beauty of that is that, like, these are patterns you might find only very specific materials in the real world. Like, you might see this in like Damascus steel has these kind of patterns in it, or like folded steel, or like really thoroughly worked handcrafted steel might have these patterns in them, but we really see it in like manufactured objects. So if you combine this with the idea that you can then bake these textures and print them on the J850 or on some other color capable printer, you start to be able to kind of control this materiality in a physical product in a really interesting way. If you are interested in that process of texture baking, you can do it in Blender. I can't remember exactly where. I think it's in the actual, I think it's in the rendering tab, but if you just Google texture baking, I think you have to do it in cycles. So if we go to bake, we can bake textures in here, and we can bake them out into images that we then use as a image texture in an OBJ file, or we can output a 3MF or something like that. But yeah, I'm not 100% certain on this process, so definitely follow along with a tutorial on YouTube to do it. I just want to make you aware that it is a possibility. But let's move on from that. So we'll have a look at some different texture types here. If we add in, the brick texture is a pretty classic. If we chuck that into color, we get this kind of the ability to kind of configure this brick style texture to create this sense of this kind of like grid, and then we can control the colors and control the shade of the mortar, in inverted commas, I guess, in between. So we have a lot of control over that. And again, like if you just kind of switch these to different shades of, if we drag the saturation down, different shades of kind of black and white, then you can always use this color in your, say, roughness map. And you can create that kind of interesting kind of quality there, or add a bump node in. Let's bump, and use that to drive the height of a bump map. So we plug that into the normal, and then we get this kind of like, it's pretty gross, but we get this this kind of interesting surface quality and material quality. Now, I do also believe, I'm not sure if this is out of beta yet, but I remember seeing something in one of the latest GrabCAD updates about being able to use bump and displacement maps within GrabCAD. So again, baking these textures out, using going in, finding a texture baking tutorial and baking those textures out, will give you the ability to actually like create textured surfaces based on these image maps. So that's a really interesting attribute of our printer, of that J850, that really no other printers, or very few other printers, actually have. So do be aware that when you're learning these processes, they're not just kind of like visual, aesthetic eye candy. You can actually utilize them in a design process, and output physical objects that share these attributes. Cool. So that's the brick texture, and there's plenty more here to just experiment with and play around with. Checker is going to pretty much do the exact same thing. We're going to plug in our texture coordinates vector, and then we are going to plug that into our base color, and you can kind of see we just get this 2-color checkerboard that we can use and start to kind of like dial in how it's mapped across the surface. If you're looking for some less practical outputs, then you can always use these in animation. Like you can animate any of these components as well, so you can create a render of these like a rendered animation of these surface qualities changing over time. So that can be kind of interesting as well. Let's have a look at a few more. So IES texture, this is more for lighting. So in Keyshot and things, you'll see that you have these IES lighting types. So if you're looking at, usually they're more architectural. They're more for architectural purposes, because they are lighting profiles that match like manufactured light bulbs and manufactured lighting systems. So you can kind of download different IES profiles and use those to create lighting maps or create specific lighting textures. We have a whole bunch of different stuff here, like Musgrave and Magic textures are really interesting, especially if you want to start generating cool patterns on the surface, or you're looking for specific qualities. This Musgrave is kind of just like a more random noise, maybe, or maybe less random noise, I'm not quite sure. So do just kind of like mess around with some of these textures. The Magic texture one is pretty cool. If we go to Magic texture, plug that into vector, that into base color, you can get some really trippy stuff going on with the Magic texture. Now, another thing that I maybe pointed out in I can't remember if I pointed out in an earlier video, is that you can use you actually process vector coordinates with noise. So if we go into our noise texture here, the staple noise texture that we might use for like our bump maps to just add texture to a surface, if we pump that into there, and then the color here into our vector, we can actually start to okay, so I keep zooming in. I'm just going to cut myself off it. I keep zooming in and clipping the model. So if you run into this issue and you want to get closer and you're clipping, your viewport is clipping, you can always make this clipping, not in here, sorry, in the camera settings. There we go. You can just reduce this clipping distance in your camera properties here, so that you don't get that clipping happening so quickly. So yeah, you can see in here, let me just increase my depth of field a little bit. You can see that in this material, if we start messing around by distorting this information coming from the texture coordinates with a noise texture, we can start doing really interesting things with the surface as well. This is a really fun experimentation process that can allow you some like really wacky and really interesting results that can give you some really pretty crazy surface qualities. And again, like, you don't have to necessarily use that. Usually if you take the factor output should be like a black and white version of your color output. So you can always use that, for example, in a bump map, or in, so you can get these wacky, really intense surface textures, or in a roughness map or in a metalness map or something like that. That might look a little bit crazy, but you can get some pretty interesting results just by experimenting with all of these different maps and mapping types and inputs, and plugging kind of colors into vectors and things like that, because a color is made up of three numbers, a vector is made up of three numbers. Like these are kind of compatible. So you can get some really interesting results just by experimenting with layering up different kinds of textures. There's also, so Voronoi is a texture is kind of interesting because it's not really what you might think. So Voronoi creates like cellular structures, right? So if we go color into base color, we'll get this kind of like choppy, like cellular, kind of cellular, I guess, distribution of color. But if we actually use distance, you can see that we start to get your more kind of, I guess, classic Voronoi look, where you have like basically this you have points distributed across the surface, and the closer you are to where one of the points is, the darker the color, and where two points are like at equal distance from each other, you get like a white color. So you end up kind of getting this cellular kind of look. Now if you put that, you can also use position into color here, but you tend to not get great results from that. So distance or color is always interesting enough. But if you drag down the randomness completely, and then you add in, let's say, a color ramp, there we go, and you start to mess around with these, you can kind of create like a dot matrix look, especially if you switch this over to constant, so you've just got like two color positions here. You can start to really get a cool kind of almost like polka dot like effect, and then messing around with the mapping coordinates and things like that can get you some pretty interesting results as well. Like if we put that to 0, you can kind of almost get, you can add a noise in here. Yes, noise. You can get some pretty wacky results from that as well. And then you can always, like, if you really want to add color back into it, You can add in, let's grab this, hit Shift D, chuck it back in here, to add in another color ramp, and then start to mess around with, yeah, we'll go linear, start to play around with the, you know, with different colors in here to create some, well, these are going to be relatively hideous, but you can really kind of create some pretty interesting results, especially if you go back to linear here. Start to mess around with how you distribute the like, yeah, basically distribute colors through this distance, right? So yeah, lots of opportunity to create some pretty hideous results, but you know, again, as I've said many times in the lecture, like keeping it more simple, layering simplicity, and using things with a bit of subtlety, you can start to create some really interesting results. So I guess as a point, I guess to try and make a point there, or make a point on that, I'm going to try and make, I don't know how well it's going to go, I'm going to try and make like a procedural wood material. It's probably not going to be nearly as good as what you might download if you just use textures, but it may be interesting. Okay, so it's not perfect. It still definitely needs a little bit of tweaking here and there. But when you apply a little bit of subtlety, and maybe just tweak some of these colors and some of these color ramps a little bit, you can kind of see that you can really start to create you know, effective textures based entirely on you know, procedural setup. So it doesn't really matter what direction or like the size or shape of this object. It should map pretty well. Let's see. Well, we say that because it's kind of it's emulating almost like a plywood, in that it's like really compressed along one on one side, which we don't actually need. We could make it just regular kind of scale. So if we, I mean, this may or may not work particularly well, but we will just see how monkey copes with that material. First, I'll just make sure that I give this material a name, procedural wood, up the top here, and then I can just go in and apply procedural wood to the monkey head. And how we're getting on, monkey? I mean, yeah, definitely needs some tweaking, needs a subdivision surface or two, and to be shaded smooth, but yeah, you can kind of see how these textures might be useful, or creating textures in this way can be useful in certain situations. I think the real benefit to this is learning how to kind of experiment and play around with node-based environments, learning how like different kinds of nodes will process the flow of data differently, because it introduces you to that concept of like procedural design and building design systems for objects and materials, that you can then translate that knowledge over to something like GeoNodes, or if you go into Grasshopper, you can translate it over to Grasshopper or Houdini or any of these procedural environments, and you kind of begin to understand how data flow works and how you can just experiment visually with creating systems for objects, rather than thinking about it too much, and getting overwhelmed by like the like surface level complexity of things. Just being able to dive in with really simple, like one node at a time, and just see how building on these systems kind of creates a interesting result. Let's turn on screen space reflection so we get some kind of reflectiveness in our surface. Cool. So that's pretty much it. I'll leave it there on the procedural textures front there. But again, if you have any questions about this process, if you want me to look over any of your work, please just send through an email with some screenshots, and I will endeavour to get back to you as quickly as possible with some feedback and some advice and some tips on where to look for different approaches to creating materials and creating environments and things like that. Cool.